study about body effect. In all the previous videos we discussed, we considered that our body effect is not there. That means our first, let us see what is body effect. Body effect means body and source are shorted. That means whatever the voltage of source is, same will be the voltage for body. And in all the videos we consider that source is taken as reference. And what does that mean? That means Vs equals to 0. That is, our source is grounded. So our Vs was 0 volt. And since our Vs was 0 volt, so we considered our Vb also as 0 volt. Because we considered that our source and body were shorted. Because we said that body effect is not there. But today we will see what happens when body effect is there. And what does body effect means? Body effect means body and source are not shorted. That is, there will be some voltage difference between source and body. That is, VSB won't be equal to 0 volt. VSB will be either positive or VSB will be either negative. There will be some difference. Either it is positive or negative, but it won't be 0. That is the meaning of body effect. Now first we will see case 1 when our body is negative. That is case 1. We take Vb to be negative, or we can say that we take VSB as positive. So what is VSB? VSB is Vs minus Vb, and since here we are taking Vs as 0 volt, so what it will be that VSB is equal to Vs minus Vb, and Vs is 0, so 0 minus Vb. And what is 0 minus Vb? Minus Vb. And since here we are writing that VSB is positive, so minus Vb will be positive. And what does that mean? That means that Vb is negative. So either we can say that our VSB is positive, or we can say that our Vb is negative. Both will be same. So if we are saying that VSB is positive, that means Vb is negative. So now we will see what happens when Vb is negative. And before seeing that, we can see one more formula for threshold voltage. So what is the formula for threshold voltage? It is Vt naught plus gamma under root 2 phi f plus Vsb minus under root 2 phi f. And in this video we are not going to derive this formula. We are just seeing that what is the effect of VSB being positive or being negative, and how it affects the threshold voltage. So if first we say that there is no body effect, if there is no body effect, then VSB will be 0. So what will be our Vt? Vt will be Vt naught plus gamma, and if we put here 0 in place of VSB, then what it will be? It will be root under 2 phi f, and it will be also 2 phi f. So this will be cancelled out, and it will be 0. So gamma into 0 will be 0. So we can say that our Vt will be Vt naught. So here we can say that when VSB was 0, our threshold voltage was same as the original. So there is no change in the threshold voltage when we consider VSB as 0. So when VSB was 0, our Vt was Vt naught, so we can say that no change in threshold voltage. Now we will see what happens when VSB is positive. It is not 0, it is positive. So we will see that. And here we will take the example of NMOS. We can also take the example of PMOS, but here I am taking the example of NMOS. So this is our substrate, and since it is NMOS, so it will be P substrate. And this is source, this is drain, and both will be of N plus type. And this is our oxide layer, this is metal layer, this is gate terminal, this is drain terminal, and this is source terminal. And our source is grounded, so we'll show it as grounded. And our body is here negative, so we will show it as negative voltage at VB, at body terminal. And we know that in NMOS we take our drain as positive voltage for the flow of current, and that we have discussed in the working of NMOS. So now if we imagine the diode in the source side, so how it will be? It will be like this, because we know that our diode is like this, and this is its P side, this is its N side. And since our substrate is of P-type material, so the P side of the diode will be here, and since our source is of N plus type material, so the N side of the diode will be this side. And since here our body is at negative voltage, so we can say that here the P side of the diode is having the negative terminal, and the N side of the diode is having positive terminal. So this diode is in reverse bias. So here we can say that this diode is in reverse bias. And what happens when diode is in reverse bias? We can write here that the diode of source side is in reverse bias, and reverse bias will lead to increase in depletion region. And this increase in depletion region will lead to electric field creation and electric field becoming stronger. And this electric field becoming stronger will lead to movement of electrons, or we can say that movement of charge carriers. But here we are considering NMOS, so in NMOS we know that our charge carriers are electrons, so here I am writing movement of electrons. So, and also we know that electric field and electron are not electron, movement of electron. Electric field and movement of electron are in the opposite direction. So first we will see what is the direction of electric field here. This is our N-type material, and how our N-type material looks like. Let me remove this. Our N-type material looks like this. Positive ion with electrons. So here our positive ion will be in the source, and our substrate is of P-type material, and we know that our P-type material looks like negative ion paired with holes. So negative ion will be here, and we know that the direction of electric field is from positive to negative. So here the direction of electric field will be in this direction, positive to negative. But as we said that the direction of electric field and and the movement of electrons are just in opposite direction. So since the electric field is in this direction, the movement of electrons will be in this direction. So electrons, whatever electrons are here, they will remain in the source, because we can write here that the electron of the source will be pushed back to the source because of the electric field. So here we can see that our electrons are not even coming out of the source. Also we can see that the diode in the drain side will be like this, and this diode is in reverse bias. Why? Because our drain is at positive voltage. So the N side of the diode is connected to positive voltage. So here we can say that it is in reverse bias. So due to this reverse bias in the diode, there will be increase in depletion region, and that increase in depletion region will lead to electric field creation, and that electric field will be in this direction. This direction. So according to this electric field will attract the electrons in this direction, because we know that the direction of electric field and the movement of electrons are in opposite direction. So since this electric field, the second electric field, is in this direction, so electrons should move in this direction. But the thing is that the electrons here are not even coming out of the source, due to which they won't be attracted by this electric field, because for this electric field to attract electrons should at least come out of the source. Then only this electric field will be able to attract those electrons and let them travel from source to drain. So here we can write that electric field due to the drain side or due to the diode of the drain side is strong enough to attract electrons, even then it won't be able to because electrons are not even coming out of the source. So since electrons are not coming out of the source, so to take those electrons out of the source, we need to apply more VGS. And what does that mean? More VGS means more VT, that is increase in threshold voltage. Because to take electrons out of the source, we need to apply more VGS, and more VGS means our threshold voltage has increased. So we can see that when VSB is positive, our VT has increased, and we can also see through the formula. Our formula was like this: VT is equal to VT naught plus gamma under root 2 phi f plus VSB minus under root 2 phi f. So if we put here some positive voltage, obviously our VT will be increased, because then our VT will be VT naught plus this term. So here we can say that VT has increased. Now we will see what happens when we take VSB as negative. So our second case is that VSB is negative, and if VSB is negative, that means our VB is positive, because our source here is taken as a reference. That means Vs is 0, and if Vs is 0, then Vs minus Vb is negative, means Vb is positive. So again we will draw that NMOS. This is source, this is drain, this is oxide layer, this is metal layer, this is gate terminal, this is source terminal, and our source is grounded, so we will show it like this. And this is our drain terminal. Our source and drain are of N plus type material, and this is our substrate, and it will be of P type material. Here we will have body terminal, and it has positive voltage, and in NMOS we know that we need to apply positive voltage at the drain. So what happens here? Here we can again draw that imaginary diode at the source side, and this time we can see that our P side of the diode is connected to positive voltage. So this will be in forward bias. So this diode will be in forward bias. And forward bias means decrease in depletion region. Decrease in depletion region means the electric field becoming weak. So here we can directly write that VB is equal to positive, means diode of the source side is in forward bias. So electrons from the source will easily come out of the and travel to drain. And if we are saying that electrons from the source will easily come out, what does that mean? That means that we don't need to apply more VGS. Here our VGS will be low, and if VGS is getting decreased, that means what? Our VT is getting decreased. Threshold voltage, we need less threshold voltage for getting our electrons from the source out of the source. So also we can see this from the formula, like if we write again that formula, Vt is equal to Vt naught plus gamma into 2 phi f plus Vsb minus under root 2 phi f. And we know here that our Vsb is negative. So if we put any negative term here in place of Vsb, this term will be less than this. So this whole term will be having minus sign. So this term will be, if we denote this whole term with x, then this will be Vt naught minus x. So here we can clearly see that our Vt has decreased. But then there is one more, there is one question, like why don't we put Vsb as negative when we talk about MOSFET? That is because when this diode is in forward bias, that means current is flowing here, and this current is taking some power, that is power consumption is happening here, and that power consumption is unwanted, because we don't want this current to flow. We just want current to flow here from source to drain or drain to source. We don't want our current to flow in this direction. So this is just unwanted. So here we can write that we don't keep VSB is equal to negative because unwanted power consumption occurs due to this. So if we first let me move this, then we will talk. First thing is that the target of MOS is to use it as amplifier. Here our target is not to decrease the threshold voltage. Here our target is to use it as amplifier. So we don't focus on decreasing the threshold voltage. But by mistake, if it happens that our VSB is not 0, if we are unable to achieve this, then we can write that if we are unable to achieve VSB as 0 volt, then our second concern will be to reduce power consumption. So we will prefer VSB equals to positive. So we will prefer VSB equals to positive if we are not able to achieve VSB equals to 0, because our second concern is to reduce the power consumption, and when we keep VSB as a negative, our power consumption was happening there and that was unwanted. So we will prefer VSB is equal to positive. So here we can write that in first case what we saw, when VSB was positive and that means VB is negative, we saw that our VT increased, and this is not desirable, that is you can write it as undesirable. This we don't want that our VT increases. But in second case also, if we see VSB is negative, VB is positive, and that means VT to be decreasing, but there is one more thing happening here, unwanted power consumption is there. So we don't want this also, so this is also undesirable. So our desirable thing is only VSB is equal to 0. So this is our desirable thing, and these two are undesirable. But if by any circumstances we are not able to achieve this, then we will go for this. We won't go for this because here we will have unwanted power consumption. So this thing should be kept in mind, that if VSB is not equal to 0, then we should go for VSB equals to positive. even if it is causing our Vt to increase. But we want to go for VSB equals to negative, because even though our Vt gets decreased, but unwanted power consumption is occurring there. So this is it for this video, and we will solve some questions in the next video. Thank you.